بيكو شريف محمد 5 كان معانا عباره replication cycle. It's a great honor for me to win I would like to talk about viral replication cycle. I'm very glad to be this co-participant in conference. When we read the notes, we learn more. Apply, we can just more and more. Today, food of life resident, HIV, human immune deficiency virus, or HIV nowadays, acute immune deficiency. By the end of my lecture, I wish to give you what is the main stage for the cycle. So if you know what is the is every by living protein composed of matrix core protein 70, nucleic acid core protein 24. We have two receptors, one is surface receptor, or it is called glycoprotein 120, and the other transmembrane protein receptor, which is called glycoprotein 41. The capsid is formed of two identical single-stranded RNA. H1 DNA is identical to the other. And we have three more important enzymes, which are integrase and protease reverse transcriptase. Let's get. Before we talk about the replication cycle, we must talk about the replication cycle. First, CD4, which is receptor found in the cell. It is active and connected to a recipient or a donor, which will be produced by HIV cell. Make a connection with each other, and then will be able to enter the cell. The next one is co-receptor or CCR5, found on the surface of macrophage, or CXCR4, found on the surface of lymphocytes. Glycoprotein 123 is sugar-free coated protein. It is with molecular weight of 120, found on the surface of the HIV cell. Integrase enzyme for encoding. Enzyme for integration. Integrase is enzyme more important. We know that viral genome of the HIV is RNA. We need it to be DNA. Then we need it to be into the host cell DNA. This is the function of integrase. Protease, when we get the cellular protein of HIV, we must take in consideration that for maturation, we need it to be cleaved. This is the function of protease. Reverse transcriptase, HIV genome is single-stranded RNA. This is non-function. To be a function, we want it to be double-stranded DNA. This is the function of reverse transcriptase, and we will say it. Steps of the cycle. As we see, early attachment, second entry to cytoplasm, reverse transcription, transported to the nucleus, entry into the nucleus, integration to the host chromosome, then expression of viral genome, translation by viral gene products, processing of viral protein, finally assemble antibody. This is summary for what I will talk about. First, HIV cell come in contact with host cell, attached by glycoprotein 120 to CD4, then thermally attachment, then fusion and penetration. Transcriptation refers that, or the opposite of the normal transcriptation of the human body. Then the RNA genome is DNA. It will be integrated as if it was original DNA of the host. Then it will be transcripted again to RNA, then translated to a protein, then come in contact to form a new membrane of the host cell, then bind. We will take every step with more details. Attachment is specific bond between donor and recipient. Donor is HIV cell, recipient is the normal host cell. It is a function of receptors. As we say, this is the HIV particle, and this is the normal host cell. This is cytoplasm. This is nucleus. Then we can found that this is nucleic acid. This single-stranded RNA protein. This is our enzyme. two surface receptors, glycoprotein 41 and glycoprotein 120. Glycoprotein 120 come in contact with CD4 receptor in the surface of host cell. We found on the surface host cell another type of receptor which called core receptors. This is called beta chemokine or cytokine receptor, CCR5 if the cell is macrophage, CXCR4 if the cell is T lymphocyte. When they bind together, they are able to fuse. They are able to attachment, Fermi attachment. Then the two membranes coming together, melting together, so the nucleocapsid will be injected into cytoplasm of the host cell. I'm quoting, when the nucleocapsid is injected into the cytoplasm of the cell, it is non-functional, as it is enclosed by nucleoprotein. To be functioning, we must put it in non-exposing state. This is the nucleocapsid will be dissolving in, releasing the genetic material into cytoplasm. We come into the most important step. In the cycle. First, reverse transcription. What is made? This process by which RNA will be converted to DNA. This is opposite the normal process that is formed in our bodies. Our body converts DNA to mRNA by the action of RNA polymerase. Reverse transcriptase will make RNA to be DNA. It will be act on the single-stranded RNA to form another copy of complementary DNA. When DNA first formed, the reverse transcriptase will degrade the single-stranded RNA and copy another complementary to the DNA. This is still non-functional. If we have a drug to inhibit this step, as my partner have said, as nucleoside reverse transcriptase inhibitor or non-nucleoside reverse transcriptase inhibitor. Integration. When the virus becomes from RNA genome into DNA genome, we must put him into the nucleus, which is responsible for most important instructions in our body. When the integration occurs, the viral genome must be transported into the nucleus. The mechanism is still unclear, but some theories expected that there is something called viral protein, or which is carried by HIV genome, will be able to make the genome bridging the nucleus and enter into the nucleus. Once it enters, it will be integrated to host cell DNA as if it was a normal member. Then we call this pro-virus or latent stage. The virus becomes latent and needs activation. If it is activated or integrated, it becomes the HIV premature virus. We have three states the virus will be able. A latent state, where no expression at all, low level of chronicity, when there is expression sporadically of the virus, and full expression when the virus is fully expressed and lyses of the cell. If expression occurs, the DNA will be transcribed into two-stranded viral mRNA. This is called the latent stage. When activation occurs of the cell, the mRNA will be transported out of the nucleus into the cytoplasm again. Added viral mRNA transported into the cytoplasm again. This is the step will be the function of ribosome, which mRNA will be translated into various protein by ribosomal activity. This protein is immature. Then function of protein enzyme, which will collect and hydrolyze this protein into small protein or collect protein. This is maturity. After that happens, the HIV subunits will be transformed into the peripheral of the cell, mixed with the cell, dissection of a membrane, and create a new membrane for it, which is the nucleocapsid, and dividing from the cell, enter the circulation, and reinfect another cell. We have a summary in this video. This is HIV virus. We can say this is surface glycoprotein. This is the lipid envelope. This is surface glycoprotein, glycoprotein 120. This is transmembrane glycoprotein, glycoprotein 41. This is the matrix core protein. This is the nucleocapsid protein, matrix core protein, protein 70, and the nucleoprotein of the capsid protein 24. Two identical single-stranded mRNA, two single-strand mRNA, and three important enzymes: reverse transcriptase, protease, and integrase. To establish infection, HIV enzyme must become in contact with the normal T helper cell. Glycoprotein 120 will be attached to CD4, and the glycoprotein 41 will be attached to the core receptors. Then fusion and penetration of the nucleocapsid will come into the cytoplasm. Viral single-stranded RNA will be reverse transcripted by reverse transcriptase into DNA. So when that occurs, reverse transcriptase will degrade the single-stranded RNA. DNA will make another copy complementary to it. Will be non-covalently attached, integrated into the cell nucleus, by the action of integrase. This is called the latent stage of activation of the T helper cell. There will be expression of the DNA into mRNA. RNA polymerase will make a copy of mRNA. This is one, this is the other, out of the nucleus into the cytoplasm again. One of them will be translated into protein. By action of proteases will be cleaved to single minute protein, will be suppressed and processed into surface receptor, and the viral RNA genome detection for part of membrane nucleocapsid coming out of the cell. We must put in consideration finally that if you are HIV positive, that doesn't mean your life is over. Thank you for your attention.